So let's provide the solution on how to find all the first and second partial derivatives of this vector valued function. So first, let's define partial v partial x. So partial v partial x, this term will get 4xy minus this term will get 4x power 3. And then we have the I vector plus here now partial differentiation. If you have e raised to power xy, y is taken to be a constant. So by chain rule, we'll have y e raised to power xy. This other part, y is a constant, so just the derivative of sine function is cos function. So minus y cos of x. And this part cosine of y is taken to be a constant because we are differentiating with respect to x. So we'll get 2x cosine of y, k. So that becomes the solution of the partial v partial x. And we can as well now go to the second partial derivative of v with respect to x, which is the same as partial x of partial v partial x, which is, now we are differentiating this first solution. 4xy will give us 4y minus 4x power 3 will give us 12x power 2. And then for the I part, y is just taken to be a constant. So differentiating this power, we get y. So y times y is y squared e raised power xy. When you differentiate a cosine function, you get a positive sign, a negative sign. So this will now be plus y sine of x j. And this now we get 2 cos of y k. So the second partial derivative of that vector with respect to variable x is 4y minus 12x squared I into y squared e raised to xy plus y sine x, and then plus 2 cosine of y k. Next, partial v partial y will get this first term will give us 2x squared. And then because this doesn't have a y, so it will be just 0. So this will be the only component of I. And then here, x is a constant. So by chain rule, x e raised to xy. And then this part here will get minus sin x. So this will be the component of j plus for k. When you differentiate cosine, you get negative sign. So we'll have negative so we get the same as 2x squared I plus x e raised to power xy minus sine of x j minus x squared sine of y k. So that is partial v partial y, 2x squared I plus x e raised to power xy minus sin x j minus x squared sine of yk. So partial squared b partial y squared. Now we differentiate this answer with respect to y. So x component will be 0 plus, at this point, we'll get x squared e raised to power xy. This will be 0 because there's no y. Differentiating this part, we get negative x squared cosine of y k. So the answer is just x squared e raised to power xy j minus x squared cosine of y k. So that is partial squared b partial y squared. Now, let's get now the mixed partial derivatives. So partial squared b partial x partial y, by definition, is partial x into partial v partial y, which is partial x. Now partial v partial y, we have 2x squared I plus x e raised to power xy minus sin x j, and then minus x squared sine of y k. So which will give us, this with respect to x will have 4xi. Now here we use product rule. So I have x e raised to power xy. This is our u. This part will be our v. U prime is 1, so we'll have e raised to power xy plus v prime will be y e raised to power xy. So in multiply by u, we get xy e raised to power xy. So I'll have now plus, so this only is e raised to power x y plus xy e raised to power xy, and then minus derivative of sine is cosine j, and then this will give us negative 2x sine of yk. So that is the partial squared b partial x partial y for xi into x y e raised to power x e raised to power xy minus cosine of x, and then minus 2x sine of y. The last partial mixed partial derivative is given by partial squared v partial y partial x, which is partial y partial v partial x, which is partial y, and the answer we got for partial v partial x is given by 4xy minus 4x cubed I plus y e raised to power xy minus y cosine of x j, and then plus 2x cos of yk. So this will give us, this first part will be 4x, second term of the component of I will be 0 because there's no y. So just for x I plus, now here we use product rule because it's y and e raised to xy. So this would be our u, this will be our v. So u prime is 1 times v is e raised to xy plus v prime is x e raised to xy times u, we get xy e raised to xy. So this will be now e raised to xy plus xy e raised to xy. And this term, when you differentiate with respect to y, you get minus cosine of x. So j, this is with respect to y, derivative of our cost function is a negative sine function. So it'll be negative 2x sine of y, k. Check that these mixed partial derivatives are the same. This answer and this answer actually matches. So we say partial squared v, partial x, partial y is identical to partial squared v, partial y, partial x. Now, whenever the partial derivatives are continuous of the second order at least, then this will always be true in general, that the mixed partial derivatives will always be the same. So that is how we were supposed to solve that given problem. Thank you.